these are the major isotopes that were released at the time of the accident that posed the most immediate health threats to the population. We have iodine-131, obviously has a very short half-life, but it's done the most significant damage, at least that we can document and attribute directly to radiation of all the isotopes that were released. The reason is, as the iodine, came down and eventually from the clouds ended up on the ground and the grass. The main way dose was received to people is as cows were grazing on this iodine-rich grass. It came out in the milk, and then as people consumed the milk, they were consuming this radioactive iodine as well. And here's another thing where it comes into just things that don't even necessarily have to do with the radioactivity as to where the most damage was done. There were some areas where the radioactivity hit the hardest that didn't have issues with iodine deficiency in the area. People's diets gave them plenty of iodine, and so because the thyroid had enough iodine to produce the hormones it needed to, it didn't need to take up as much of the radioactive iodine that was introduced into the system. A smaller percentage of it would be taken up by the thyroid, the rest would all just be urinated out, and it wasn't that big of a deal. Now those who live in iodine deficient areas, their thyroids were sort of like a dry sponge and just soaked up all of as much of the iodine as it could that entered their system. And so in that case, you're going to have a whole lot more radioactivity in the thyroid, and it ended up being exactly that. They had graphs showing from before the accident approximately where different iodine deficient areas were versus areas where people were getting enough iodine in their diet, and graphs of where the worst radioactivity fell. And if you compare the two, really it's sort of a mixture of the two factors. Both iodine deficient areas, they're going to get forced doses to their thyroids, and areas where there was just a whole lot more radioactive iodine dumped on the ground. Then you have radioactive cesium and radioactive strontium. Obviously, with the Chernobyl accident, we're still not even up to the first half-life, and generally speaking, you want to wait. After 10 half-lives, you can consider it more or less gone. So we still have a long way to go with those.
When was that photograph taken? Right after the accident and before they go to sarcophagus?
I'm honestly not sure.
There's no smoke. Doesn't look like it's structured very well.
My guess is that it was sometime right after the accident before the sarcophagus was put up. And just for looking at why the radioactive strontium and cesium are such a big deal, obviously. Cesium is going to act exactly the same chemically in the body as potassium, which is going to get used all over the place in the body, and strontium is going to act the same as calcium. So our bodies are going to treat those the same way, and hence they pose a greater threat. Our bodies will use those chemicals, whereas a lot of other ones, our bodies don't necessarily use chemicals of that nature at all, and so they just be put out as waste. As I said with the iodine, the way they really noticed this was in children. With adults, you can see the numbers here from 100. It does rise, 800 times higher. Whereas with children, the increase was even more significant. Generally, children don't tend to get cancer as much anyway. The reason it affected children more in children, their thyroids are larger proportionally than they are in adults. Children tend to drink more milk than adults do, and that's the main way that they were getting the radioactivity into their systems. From everything I've read, it looks like 7 children died of thyroid cancer. And this was fairly early on. I think it was around 91, 92. And it was at that point that they actually recognized, wow, look, there's an enormous spike in the incidence of thyroid cancer. We need to start watching for this. And since they've watched for it, they haven't had any documented deaths from thyroid cancer. It's a very treatable cancer, usually has a 95% recovery rate. So it's just something that they really weren't expecting at all. The only thing they had to go on after the Chernobyl accident in terms of what's going to happen to human health was what they had learned studying Hiroshima and Nagasaki. But the levels of radiation doses that were received where the bombs went off versus the Chernobyl accident, where some radioactivity was released into the atmosphere and then settled, there's a really big difference in terms of the doses. And they have dose models based on all the data that they've accumulated from Hiroshima and Nagasaki that will determine, you know, if you get this much radiation dose, then your chance of cancer increases by this much, or deterministic effects as well. If you get this much dose, you're going to have this much damage. But with Chernobyl, it was in an area that's still debated as to what actually happens, which kind of dose model you're going to follow. When you're getting lower doses of radiation, there's still a lot of debate as to what actually the health effects are from it. They've recently discovered that the cataracts, you can get radiation-induced cataracts. They originally thought that there was a threshold dose level for that, and as they've studied it more and more, they now know that there actually is no threshold at all for radiation-induced cataracts. So any amount of radiation that you're exposed to increases your chance of cataracts immediately.
How about x-rays? Would that do it too?
Yeah, depending on the amount of x-rays that you're exposed to.
Yeah.
So this was the thing that kind of surprised them the most, and it's one of the few things that they've been able to directly attribute to radiation-induced health effects.
Do you have the numbers on that threshold? It's very hard to measure thresholds down low levels. So I'm just wondering if they have, when they say there's no threshold, a lot of people say there's no threshold for cancer, but it's very, very hard to measure experimentally once you get down to a few grams.
I'd have to look up the information on that case study. I don't recall all the details with it, but I know it was actually a pretty recent study. It's only been in the past year or two.
Mm-hmm.
And I think they just went back and they've been examining both the Chernobyl people who've had to have like numerous amounts of x-rays, just all the different radiation-induced things, and they haven't been able to find any threshold at all as they've mapped out.
Well, you can't get that from people who have huge doses. You can only get that from people who have very small doses.
Mm-hmm.
And for ordinary cancer, the project required 10 to 100 million mice to be able to even do the experiments.
Mm-hmm.
So I'd be interested in knowing how they could. There must be some level beyond which they haven't measured that.
It's possible.
Why has I mean, if you look at the graphs, you look at the children and the adults, I mean, clearly you're right that you can see that the children's graph has a much bigger spike on it. Why has the adults graph kept on going up, whereas the children's graph is clearly going down?
Children
become adolescents.
I think what actually it is, I believe they actually have an age range, and so some of the children who were children at this age and children at the time of the accident, they'll then group them into the adolescent group.
Yeah, okay.
And then they'll group them from the adolescent group into the adult group. So.
Well, I'm confused about those plots. What is the control thing? I mean, we know they really started searching for thyroid cancer when this happened. Mm-hmm. So how is that compensated for in these plots?
I don't think that it is compensated for.
What is the lower plot?
Issues. The lower plot is this is cancer of the thyroid in adults.
Oh, children, adolescents, and adults. Okay,
Yeah.
Thank you.
Why was this a surprise? I seem to remember only vaguely from the 60s that with all the tests in Nevada and so on, that there were worries about iodine, and that you could take iodine in order to flush out any bad stuff and so on. I would have thought that would be the first thing they would have thought of here. Was it just Soviet incompetence?
That's my guess, is that it was just Soviet bureaucracy.
Doesn't do you any good to take the iodine pills a week after.
Yeah,
No, but why wasn't why a week?
It's the Soviet Union.
Yeah, right. Okay.
Interestingly enough,
And they were still drinking the milk
Yeah.
from cows grazing.
Yeah, I was going to ask that question
the government
earlier.
wanted to keep it a secret, and so a lot of the population wasn't even part of it until weeks afterwards. I believe so.
But Gorbachev was in charge, and they announced it almost right away to the world. And it was actually the head of the U.S. I guess it was Intelligence Committee, who berated the lying Russians for claiming that the chain reaction had stopped.
Yeah.
And this was on public TV, where he's saying, obviously, anybody who knows anything about nuclear reactors knows that chain reaction hasn't stopped. It was a U.S. intelligence senator.
Yeah. It's
So there's a lot of misinformation going on. I mean, the trouble is people in charge don't understand this stuff at all.